Hello and welcome in this session of the course Pedagogy of Science. I am Dr. Gaurav Singh, your course instructor for this course. And we are basically talking about content cum pedagogy approach. We are discussing few topics from a secondary school science curriculum, and we are trying to facilitate you that when you will deal with these topics in your classroom, what kind of teaching learning strategies you can adopt, how you can engage your learners, how you can give them opportunities to explore more, how you can explain, how can you evaluate. All these things we are basically discussing here. So the topic which I have chosen today is from the theme light. And the title of the topic is Refraction and Refraction. Actually, when we enter in our class at the secondary level, light is not something which our students don't know. They know many things about light. They know the sources of light. They know that light travels in a straight path. They know what are the natural sources of light, what are the man-made sources of light. They also know various uses of light, whether it is the use of camera, whether it is use of electricity, whether it is use of sunlight, and they also have some basic ideas about lenses and mirror, because from the childhood they are using mirror at their home. They have seen spectacles at their home with the elders in the family. So they are well aware about the concept of lens, they are well aware about the concept of mirror. We need not to teach these topics again and again when we are dealing with these topics at secondary level. So how can we start? I am suggesting you a few ways. Like you can start with taking examples of the uses of mirrors from your students. You ask your learners to tell you that what are the various uses of mirrors they have observed at their home, in the neighborhood, or in the society, in the parking, in the mall. They must have seen different types of mirrors. Or if you have a good laboratory with different types of mirrors, give them different types of mirrors. Let them experience the types of images being formed in those mirrors. Ask them to note down the differences, notice the differences in the images in different mirrors. Even you can use some kitchen utensils which basically reflects and work as mirror. They can also see what kind of images are being framed there. So they may told you or they may report in their notes that some images are long, some images are short, some images are round, some are distorting the shape, some are erect, some are inverted. So these will be some common observations of your students when they try to find out that how image is being formed in different types of mirrors. Now the question is why it is happening. What is the reason for it? To explain that reason, you need to explain or you need to help them in recalling the laws of reflection which they have already studied at elementary level. Laws of reflection are also in the science curriculum of elementary level, maybe in class 7 or class 8. So let them recapitulate. You ask them to present and they will tell you that if it is a plane mirror or it is a mirror, the angle of the incident is equal to the angle of the reflection. What is the angle of the incident? The angle between the normal and the ray of incident, and the angle between normal and reflective ray. So the incident ray, the normal of the mirror and the reflected ray all lie at same place, in the same plane. When they reflect or when they recall these laws, now you ask them whether they have seen the spherical mirrors too. Because at elementary level, we have talked about the normal mirror. We have not talked about the spherical mirrors. You ask them whether they have seen such mirrors, what are the uses of such mirrors, what are the features of the images which are formed with these mirrors, and do they know that how image is formed with those mirrors. These are the few questions which you need to ask, which they need to reflect on the basis of their daily life experiences and observations. For example, they may have seen a spherical mirror at the corner in a society, or at the corner where 2 or 3 roads are merging and one road is not visible from the another road. They must have observed the mirror in the car, the side mirror. Can you ask them what is the difference between the images formed by the car mirror or the mirror which has been installed at the corner or at the joint of 2 roads in your colony or in a society? Let them explore. You can give them this task also, that today you go and watch the types of images with all these things at home, and when you come back tomorrow you just note down the characteristics which you have observed, and we will discuss about that. So in this way you will basically connect the concept of spherical mirrors with the learner's experiences. There are basically 2 types of spherical mirrors: concave mirror and convex mirror. So here it is the concave mirror. Concave mirror is the mirror where the hard surface is the outer part, where polish is there, and the depth is at the inner surface from where the light is being reflected. So here you can see that from which side light is coming, the arrow is showing, and on the same side the reflection will be there. Now there are some terminologies which you need to introduce to your learners before telling them that how image is being formed in the mirrors. The line which is passes through the focus and the center of curvature is basically the principal axis. Then what is the focus? What is the 2f? All these terms you need to explain to your learners, because when you will explain these, only then you can introduce the rules of reflection for concave mirror. What are the rules? Any incident ray traveling parallel to the principal axis on the way to the mirror will pass through its focal point after reflection. So if a ray is traveling parallel to the principal axis, this is the principal axis, the ray is traveling, when it will return, it will cross the principal axis at a point, that point is called focal point. Similarly, if an incident ray is passing through the focus, either this way or this way, when it will be reflected as a parallel to the principal axis. These 2 roles. And if any ray incident parallel to the principal axis, it is reflected passing through the focus. Here you can see, in example picture 1, a ray is coming parallel to the principal axis, and after reflection it is going through the focus. The image just below that is also showing the same. Similarly, if an image will come through the focus, the incident ray is coming through the focus, the image is reflecting back parallel to the principal axis. If an image is coming through the center of the curvature, it will return on same way. And if a ray is coming at the normal, then the angle of the incident and angle of the reflection will be the same, and it will return on with the same angle on the opposite side of the principal axis. So if you explain these rules of reflections, not only the images, my suggestion is use the concave mirror and convex mirror. You can have a laser torch with you. So in a dark classroom, you can use 2 or 3 colors of the laser torch, and with that you can explain easily that when ray is coming to the principal axis, parallel to the principal axis from where it is reflecting, and when a ray is coming from the focus from where it is being reflecting. Why these rules are important? These rules are important because if your students will understand these rules, they will be feeling very comfort when they will draw the ray diagram of any image which is being formed. So what you can ask to your learners after this, that why concave mirrors are used as reflectors in torch or the headlight of the car or scooter. What is the use of concave mirror for the dentist or for examining the eyes, ears, nose and throats? Because doctors are using concave mirrors. In torches we use concave mirrors. In the headlights of the cars or scooters we use concave mirrors. Why? Because light get reflected in an angle, so it expand. It not converges, it basically diverges. So for diversion of the light, to cover more area, we basically use concave mirrors there. Then we can talk about the convex mirror also. In the convex mirror, the reflective surface is the upper surface or the surface which is coming up, whereas the surface which is having depth is called hard surface or the polished surface. So that surface is not reflecting. Now here the focus is on the principal axis, center of curvature is there on the principal axis. The light comes from this side and light got reflected from the reflected surface. Let us see some examples. Here you can see that if a ray is coming parallel to the principal axis on convex mirror, it is being reflected in opposite direction, but if you extend that line to the focus, that line will touch to the focus. Similarly, incident ray is coming in the line of the focus, it is being reflected parallel to the principal axis. If ray of light is coming towards the center of the curvature, it is reflecting back with the same path. And if a ray of light is falling at the point P, it is reflecting with the same angle on the opposite side of the principal axis. So here also these four rules are important when you talk about the reflection from the convex mirror. How can you link it with the daily life experiences? There are rear view mirrors in the vehicle, which are sometimes called wings of the car. There we can use. We are using it as making the magnifying glasses. Even in the ATM for the security, inside the building sometimes for security, such types of mirrors are being installed. Let them visit, let them try to identify that what are the characteristics of these mirrors and let them correlate it with the properties of image formation which have been discussed by you and explained by you in the classroom. How can you evaluate that whether learners have learned that how image is being formed in the mirrors? My suggestion would be, give them different types of mirrors, let them place the object at different places and let them try to find out where image is being formed and whether the image is erect or inverted. So you can ask them, you can give them to one team concave mirror, to one team convex mirror. Let them put the mirror in different positions, sometimes at focus, sometimes at center of curvature, sometimes at 2F, sometimes at beyond 2F, sometimes between 2F and F, sometimes at a distance which you can say it is coming from the infinity. Now, if they are putting object at different places, let them note where image is being formed. So the place of the image is also to be noticed. What is the size of the image, whether it is of the exact size of the object, whether it is smaller than the object, whether it is longer than the object, and whether it is a true image, inverted image, or it is a false image. When they do it on their own, when they fill this table correctly, your objective will be achieved. that yes, my learners have learnt that how images are being formed by the mirrors. From mirrors, let us move towards the lenses. So, the phenomena related to lenses is called refraction. Because in mirror, light do not pass through the mirror, it just get reflected by the mirror. But in lenses or in other transparent medium, light passes through the medium. How can you introduce this to your class? You just put a pencil in a glass or in a beaker which is filled with water and ask them to observe what is happening. They will tell you that pencil is not the straight, it is looking somewhat tilted. You give them different shapes, different size of different size of pencils. Let them try whether the observation is same or not. One more thing you can do, you can give them different types of liquids, not only water, which are a little bit transparent so that they can observe that whatever has been dipped in it is visible or not. You can give them kerosene oil, you can give them the edible oils which we use at home, you can give them honey, many things you can give. And then you ask them that if they are putting the pencil at the same angle, so are they noticing that the tiltedness in the pencil which is dipped in the liquid is same or different? They will definitely told you it is different. The angle is different for each medium where the pencil is being dipped. You can give them one more activity. You give them a rectangular thick glass piece and ask them to put it on their textbook page and observe. Is there any change? They may tell you that the words below the glass slab are coming up and larger. Why is it happening? Why is it happening? It is happening because when light passes through from one medium to another medium, its direction get affected from the concentration of that medium. It means light is not passing with the same way in different mediums. You can give them a water glass and ask them to put some small balls, marble pieces or lemon into it and let them observe whether they may observe any change in the shape of those colored marbles or a small ball or the lemon. They will observe. Why it is happening? It is happening due to a phenomena called refraction. So before these observational activities, it is my suggestion that don't introduce the concept of refraction directly. Give them different types of examples, give them different types of materials. Few I have suggested to you, few you may have in your mind. Then you tell them that light generally travels in a straight line, which is called rectilinear propagation of light. But when it passes from one medium to another, it bends. You explain the examples. When they were observing the pencil outside, it was in the air. But when they dipped the pencil in the water, the medium had changed from air to water, the medium had changed from air to oil, the medium had changed from air to glass. So there are different mediums which are changing. More denser is the medium, the pace of the light will be slow. And this slowing basically causes the change in the direction of the light waves, or we call bending. So the bending of light as it passes from one medium to another is basically known as refraction. Very famous experiment which is being basically suggested at all secondary level classes is an experiment of a glass slab. where you ask your students to put it on a white paper. Either you can use a glass slab or you can use a prism, whatever you want to use, you can use. Then you put a line or you put some pins on the line on one direction. You draw a straight line, then you draw one incident ray where you put different pins, and you ask your students that where they are observing the pins from the another side. They will mark those points on the paper and they will draw a line. Then they will themselves observe that the point where the incident ray is coming and the point from where the refractive ray is going are not same. They are different points. It means that light is not moving from air to glass in one direction. Similarly, when light is coming outside from the glass to the air, it is again changing its direction, and this changes direction is due to the density of the medium. How you can explain the concept of lenses here? Students at elementary level have already understand that what are the lenses, what are the types of lenses. Generally they have studied about 6 types of lenses. Biconvex lenses, the lens which is bubbled up on both the sides, that is called biconvex. Plano-convex means one side plane, one side convex. Positive meniscus means one side convex, one side little bit concave. Similarly, biconcave is there, plano-concave is there, negative meniscus are there. So there are 6 types of lenses basically, which are being used for different purposes. If you talk about the convex lens, here you again need to introduce few terminologies like focus, like incident ray, refracted ray, 2F, center of curvature. Everything you need to explain and present to your students before asking them to draw some ray diagrams. Similar is the case with the concave lenses. So what are the laws of reflection? There are also the laws of refraction. The incident ray, the refracted ray and the normal to the interface of two transparent medium at the point of incident all lie in same plane. As you can see in the picture, the normal NO, the incident ray AO and the refractive ray OB, which is in the glass, are lying at the same plane and at the same point. And the ratio of the sine of the angle of the incident and the sine of the angle of the refraction is always constant. Sine I over sine R is a constant for the light of a given color or for the given pair of media. If you will change the media, this ratio will change. If you will change the color of the light, this ratio will change. And this law is basically known as Snell's law of refraction. Snell's law of refraction, not reflection. I told you there is an error in the title. These are laws of refraction. So, this law basically works only if the angle of incident is less than 90 degree and more than 0. So, if I is the angle of incident and R is the angle of refraction, then sine I over sine R equal to constant. And this constant value is called refractive index. This constant value is called refractive index of the second medium with respect to the first one. Now, how convex lens works? At the childhood, we all have done this experiment. Even many students have done this experiment, that we give them a convex lens, they put it in front of the sun and they try to converge the rays of the sun to a point at the paper and paper got burned. Now you need to explain the concept of refraction with this example. This experiment they have done, but they may not be aware it is happening only due to the refraction of the light, because sun rays are coming from the different lines. When they are converging at a point, when they are passing through a convex lens, then the impact of the rays increases, the heat increases, which basically is the cause of burning of the paper. So, how images can be formed by the lenses? Again, there are certain rules, like a ray of light from an object, if it is coming parallel to the principal axis, whether it is convex lens or it is concave lens. If it is convex lens, it will pass through the principal focus of the other side of the lens. But if it is a concave lens, it will appear to diverge through the principal focus located on the same side, the side from where the incident ray is coming. It will appear, but it will actually go to other side. Similarly, if a ray of light is passing through the focus, or in the convex lens, if it is passing through the focus, after refraction, it will be parallel to the principal axis. But if in case of concave lens, a ray of light which is appearing to meet at the focus will be the parallel to the principal axis after refraction. And if a ray of light will pass through the optical center of the lens O, it will return or it will emerge with the same line without any deviation. So, if you introduce these three things to your students, they will be able to make the correct ray diagram of the image formed by the lens. For example, if an image is at infinity, means all rays of light coming from that image are parallel to the principal axis. From there they will pass from the focus of the other side. So, the image will be framed at the focus in the form of a point. But if an image is between infinity but before 2f, then you can see that the one ray is coming from the top of the image, which is passing through the optical center, and the one ray which is coming to the principal axis is passing through the focus. Both are meeting where? They are meeting between 2f and f. So, if an image is beyond 2f, so if an object is beyond 2f, its image will be formed between f1 and f2, f and 2f. It will be inverted and smaller in the size. Similarly, if an object is as 2f, its image will be formed at the 2f on opposite side, inverted but of the same size. If the object is between 2f and f, its image will be formed beyond 2f, larger than the object and inverted. So, in this way, if something is at f, its image will be formed at infinity. If something is between f and o, its image will be formed erected, but not the true image. Its image will be formed erected, not the true image, at the same side of the object, beyond the object and beyond 2f. That is why here you can see that we have shown the image by the dotted line and not by the exact line. Similarly, you can explain that how image can be formed from the convex as well as concave lenses also. So, what do you need to do again? You give your learners different types of lenses, an optical bench, some object or a candle. Let them experiment. Let them put image at different places, let them place lenses at different places, let them try to find out where is the image, what is the size of the image and what is the nature of the image. So, position of the object, whether it is on f, whether it is on infinity, whether it is on 2f, whether it is between infinity and 2f, whether it is between f and 2f, whether it is between f and o, and where the image is being formed. What is the position? What is the size, whether it is smaller, same size or larger? What is the nature? Whether it is true image or false image. So if your students are able to fill this table after the experimentation, it means your objective has been achieved. So my suggestion is that if in a class of secondary level, you are going to introduce the concept of reflection and refraction, introduce it through different types of activities and give a lot of opportunity to your students to experience. If they will not be able to experience it, if they will not be able to experiment on their own, they will always do mistake. Either you ask them to draw a ray diagram or you ask them to tell you any example from their daily life, because we need to connect the life, we need to connect the experiential learning when we are talking about teaching learning in science. So I hope that this video will help you in explaining the concept of refraction and reflection in your class. Thank you very much.